Okay, so we were talking about how to find the location along X for the resultant force. So again, it's the same concept. So now we say the moment of Fr, okay, about y-axis passing by O is given by the value of x prime, which is the distance between the resultant force and y-axis, times Fr should be equal to integral over the area of x times elementary force dF. And the elementary force is PdA, and P is replaced by P0 plus rho GH. So now, when I do the integral, I will decompose it into two parts, this one and this one. P0 is constant, I take it outside of the integral, and integral x dA can be replaced by x as the centroid times total area. While now for the second term, if you remember in the last derivation, here we were multiplying y by y, so we got y squared. Now we are multiplying x by y, so your integral will be xy dA. This is what is called product of inertia. Okay, so this is product of inertia, and also this is a characteristic of the geometry of the surface. So now when we are done with this section, we will go together over a formula sheet. You will see that for all typical surfaces, rectangle, triangle, circle, we will have formulas for both second moment of inertia about a certain x-axis and product of inertia. Okay. Now, if I consider the position to find x prime now, all I have to do is to divide by Fr. And again, the same procedure of demonstration, okay? You can use the parallel axis theorem to relate the product of inertia, because the product of inertia at any point O, okay, can be related to Ixy about a certain point O, can be related to the product of inertia Ixy about the centroid, plus, okay, plus the area of the surface times x of the centroid times y of the centroid. So using this parallel axis theorem, you can then find this expression for x prime. So x prime is x of c plus rho g sine theta Ixy with respect to the centroid. Okay, so also, as you can see, always we go back to values of I with respect to centroid. Okay, because in formula sheets we give them always with respect to axis passing by centroid. And if you want to use the parallel axis theorem, you can deduce inertia about any other axis. And here also, this is the general formula that is always applicable. Now, if in particular, if P0 is negligible, then I can apply this formula. So just please keep in mind, what is the condition to apply this formula? P0 is neglected compared to the pressure induced by the flow. I know this might seem somewhat complex, but now, as you will see when we'll do problems, you will see that it's simple to apply. Okay. Any question before we proceed?
دكتور
Yes.
بس هنضيع هون بين الاوريجين والسنترويد، ما عم بعرف اي وحدين هن.
Okay. Okay. I will go back to the figure here. Look, this is, I will go to the surface, to the slide of the two views. Okay. This is, in this view, this is the origin O. Okay. And this is the centroid C we were talking about. C is, if you want, anywhere here. C is here. Okay. Somewhere, this is the centroid of your surface. Now, FR, the point of application of FR is not passing by C. So if you put, for example, here, let's say when you refer to the position of the point of application, it is below C and along X, okay, it can be to this side or to this side, depending on the product of inertia. Because you have some surfaces having positive product of inertia IXY, others can have negative product of inertia. So for the position of point of application, it should always be below the center C, but it can be to the right or to the left, depending on the geometrical properties of the surface. So this is your centroid, okay? This is when we say C is the centroid of your area. This is your point of application or center of pressure, okay? So it depends on the geometrical property of the surface, you can determine it. And this is your origin. Oh, okay. So now what is the idea? The idea is I want to find at what distance X prime and Y prime should I replace the distributed load to have equivalences. So all the calculation we did was to find what are X prime and Y prime of the center point CP. Okay, CP is the center point of pressure or point of application of the resultant force. Okay, now when we say YC and X of C, so we are referring to the coordinates of the centroid of the area. So this is YC and this is X of C. Okay, and here in this figure, when you project, you can just see Y, you cannot say see X. So this is, if the centroid is here, let's say it's projection, this is Y of C. And this is the center point, which is always below the centroid of the area. This is called CP, center of pressure. And this is Y prime. Okay. Is it clearer now?
Yes, thank you, doctor.
Any other question on this? Okay. So now, as I told you, how to determine the values of your first moment of area and second moment of area along XY and product value, you have to go to formula sheets. Okay, this is a formula for the main geometries that we can encounter. So for example, if your surface of interest is rectangular, then this formula sheet will tell you that if I have an x-axis passing by C, the centroid, and the y-axis, and of course they should be parallel, this axis, x and y, should be parallel to the sides of your rectangle, okay? So you cannot take them inclined, you should take them in this way. And then to calculate the inertia, for example, if I consider x-axis, if I want to find I, x, x, okay? To find I, x, x, I should look at what is the distance that is parallel to x. The distance parallel to x in this rectangle is equal to A. What is the distance perpendicular to x in this rectangle? It's equal to B, okay? So now I can say that I, x, x is equal to A times B cubed over 12, okay? And now you can deduce, similarly, if you want to find I, y, y, so inertia about y-axis, okay? Second moment of inertia about y. It will be given by I, y equals to what? Who can tell me? You should look at the line that is parallel to y. What is the side that is parallel to y? Its length is B, while the side perpendicular to y has a length of A. So what will be inertia I about y? Second area moments about y, it will be equal to what?
BA for 3 over 12.
Very good. BA cubed over 12. Okay. So you will look at what is your axis of interest. So in general, when we talk about our application, our axis of interest will be this one. So here, if I look at this surface, I will look at the inertia about axis that is this one. This is x prime axis. This is x axis passing by the centroid. So let's say our centroid is here. This is our centroid. Okay. I will take the axis passing by the centroid that is parallel to what? That's parallel to x axis. Okay. So here, if you want, in this figure, this axis will be perpendicular to the screen. Okay. So here you will use inertia about the axis perpendicular to your screen, which is perpendicular to the plane of inclination and the free surface. Okay. This is the x-axis we consider. This is x-axis. And we'll do now a lot of practice on this. Okay. Now, what also is interesting for us in the formula, we need the value of Ix, but also we need the value of the product Ixy. Now, what is nice for Ixy is 0 whenever I have a symmetrical axis. So if x-axis or y-axis are axis of symmetry of the geometry, automatically Ixy, the product, is 0. So here, this is why they didn't put what is Ixy for you, because whenever you have one axis of symmetry, or y or x, Ixy will be 0. Okay. Now, for a circle, if you just have to know what is the value of the radius. If you have a circular geometry, then inertia about x-axis passing by the centroid is pi r4 over 4. And of course, also here, the product of inertia Ixy will be 0. This means what? This means that your center of pressure, okay, will be along y-axis. Because look, if you go back to this figure here, okay, we said that to locate the center of pressure, once I know the position of the centroid, I will find the position of the center of pressure by finding xCp and yCp. Okay. Now, in case Ixy is 0, what will happen? What will happen is that if you refer back to the centroid, x of c will be equal to x of center of pressure. And you can see this if you go back to the formula, because from the formula, how to locate x of the center of pressure, this is your formula. X of the center of pressure, x prime, is equal to x of the centroid of area plus Ixy over ayc. So whenever your surface is symmetrical with respect to x-axis or y-axis, this term will be equal to 0. So what do you deduce then? So for a symmetrical geometry, or for any geometry having a product Ixy equals to 0, then I will have x prime equals to xc. So the centroid and the center of pressure will have same x, but they always have different y. Okay? Because for y, what is the formula? For y, you have y of the center of pressure is equal to y of the centroid plus a certain positive value. So it's always, the center of pressure is always below the centroid of the area. They can have same x coordinate, then they will be along same line, the line which is this line. They will be both along, so you can see it, you cannot see it here, you can see it in the 2D view here on the top view. So when Ixy is 0, this is what will happen. Okay, you will have, this is, let's say, the centroid. This is x of c. Then the center of pressure will be just below it and will have same x. Okay, so in this case, x prime and xc will be equal, but y prime and yc will always be different. Okay. Any question on this?
دكتور إذا
Yeah.
بس الأكسس and axis of symmetry كمان ال IXY 0
Yeah. Is the O axis Hassan or Y axis? Both. And if one of them are axis of symmetry, then IXY is 0. You know why? Because look, how the IXX, what is the definition of IXX? IXX is integral over the area of Y squared dA. Okay? While the product of inertia IXY is equal to integral over area of X times Y times dA. Okay, so imagine if you have a surface, any surface, if Y is an axis of symmetry, for example, then what will happen? For any Y, for any level Y, if I take an element here, I will have with a certain X, I will find this an element that is symmetrical with a negative X. So each element will have another one that will cancel it, because one will have positive X, one will have a negative X. So when you add them, they will cancel out. So whenever one of the two axes are symmetry or an axis of symmetry of your surface, then the product will be 0. This is valid if Y is axis of symmetry or if X is an axis of symmetry. Because if X is an axis of symmetry, if I have any element here of, let's say, negative Y, I will have another one of equal positive Y that will be opposing it. So when I do the addition over the whole area, these two elements terms will cancel out. So it's enough to have just one of them as axis of symmetry to ensure 0 for IXY. And of course, for the rectangle, both axes are axis of symmetry. So automatically IXY is 0. Okay?
Yes, doctor, thank you.
Welcome. Yes. Yes, I will explain it again. Someone is asking me why we can use the formula only when P0 is negligible. Because look, if you go back to this formula, okay, this is always applicable because we derive it for any case. This is a general formula. Now, how we derived this one? What was the condition to go from this relation to this one? Okay. To be able to go from this relation to this one, you should replace FR. We know that what is the general expression of FR? FR is the pressure at the centroid times the area of the surface. Okay. Now, the pressure at the centroid is, if I know the position of the centroid, I just look at H of C. So it's equal to rho G H of C. But plus what? Plus P0 times A. Now, what will happen if P0 is very small compared to rho GHC, then I can neglect it. And this will lead to a simplification. Why? Because look what will happen. You will have here rho G sine theta times IX passing by the centroid. So this notation in some books you will see it IXX with a certain here. This symbol is that passing by the centroid, or you can see it like this IXC. So x-axis passing by the centroid. So over what is FR for the particular case where you can neglect P0? It's rho G HC times A. Now I will replace H of C by YC sine theta. So what will happen then? Look, rho G will simplify, sine theta will simplify, okay, and I will just get IXC over YC times A. This was not possible, this simplification was not possible if P0 is not negligible compared to rho GHC. So this simplification is only valid when P0 is negligible compared to the other term. Okay? Any other question on this? Okay. So now, going back to our formula sheet. So as you can see, for example, here you have formulas for rectangle, for circle, for an ellipse, for a triangle. So as you can see here, let's say for different shapes, okay? You can have all the properties that you need. So all you have to do then, whenever you determine what is the shape, you go to your formula sheet and you find what is Ixx and what is Ixy. For example, here for a quarter of circle, the x-axis passing by the center is not an axis of symmetry, and also the y-axis is not an axis of symmetry. So in this case, Ixy will be different than 0. Okay, you can have, just you should know that for some surfaces, even if they don't have x or y axis of symmetry, integral xy will be 0. Okay, so this is the condition is, if you want, sufficient but not necessary. And it's sufficient to have x or y as axis of symmetry to have 0 Ixy, but it's not required. So you might have surfaces where x and y are not axis of symmetry, but as you do integration, you will get 0. Okay. So now let us do a problem to try to see how we can apply our knowledge on numerically, okay, on a certain problem. So here in this problem, we have the 4-meter diameter circular gate is located in the inclined wall of a large reservoir containing water. And they gave us gamma of water. So gamma, when they give you gamma, this is rho times G. The gate is mounted on a shaft along its horizontal diameter, and the water depth is 10 meters above the shaft. Now, we want to first determine the magnitude and location of the resultant force exerted on the gate by the water, and the moment that would have to be applied to the shaft to open the gate. Okay, so let us start by the first question. So let us go to our figure to understand a little bit what we have. So we have a reservoir, and this reservoir has a certain opening at the bottom level through a circular gate. Okay, so first, what is the geometry of our surface? It's a circle. So if we want to find inertias, we should go back to the formula sheet and say the surface of interest is a circle. So since x and y are axes of symmetry, so of course Ixy here is 0. And now for to find the inertia about x-axis, all I have to do is to do pi r4 over 4. Okay, so now let us go back to our problem. What do we have here? First, the free surface is exposed to atmosphere. So whenever the free surface is exposed to atmosphere, you can consider that you have a negligible pressure P0 compared to the water pressure. Okay, so especially here you have 10 meters of water. It's not a small, very small depth. If you have a very small depth, then maybe P atmospheric P0 will not be negligible. But here PC is large enough because you are multiplying by a very large depth. So of course you can neglect P atmospheric compared to rho GHC. And then what can you use? You can use this formulas. Of course, the general will always be applicable, but this is simpler. So now you can use this one. You can use it because P0 can be neglected. It's not wrong if you do this one. You can try. You will get very similar results. Okay. So this is always applicable. This is only applicable if P0 is negligible. But here we can apply it since at surface level we have the atmospheric pressure, which is negligible compared to the pressure created by 10 meters of water. Okay, so now let us go back to our problem. First, they want us to find what is the resultant force on the gate and where should be its point of application. Let us start first together by finding the resultant force Fr. What is the formula for FR? FR is the pressure at the centroid of the area times the area. Okay, so here, since it's a circular gate, the centroid of the area will be just at the center. If you look at this figure, this is your center. Okay, the depth of your center is 10 meters. So this depth is given in the problem. It's equal to 10 meters. Okay, so since I know the value of the depth, then I can simply find that the resultant force, okay, equal to, since we neglected P0, we can write instead of PC gamma of the fluid times the depth of water, HC. Here, HC is 10 meters. So this is HC. Okay. And now we got the magnitude of the force. Now we move to finding the location of the resultant force. So in order to find the location of the resultant force, I need to find X and Y, okay, of the center of pressure. But here, since you have a symmetrical surface, what will be IXY? IXY will be 0. Okay, since X and Y are axes of symmetry. So what can you deduce? You can deduce that your center of pressure will have the same x of the centroid. So they will be at both along this line. You only have then to find what? To find the center of pressure location below C. So it will be, of course, below C. So all you have to do then is to find, or you just find the distance between C and the point using the formula here, because we have seen together. So this was the general formula, okay? This is the distance of the center of pressure below C. If you compute this term, you will get the position of your center of pressure below C. Or if you want to refer to the top surface, you have to add to this term Y of C, okay? So it's up to you. You can use any formula you want, just you should understand each term represents what, okay? So if you just calculate this term, this represents the distance of the center of pressure below point C, okay? While if you add YC to it, then you are measuring its position from the free surface. So let us see here how we can apply this. Going back to the figure. Okay, this is the free surface. This is the free surface. If I want to locate the position of the center of pressure from the free surface, okay, so then my axis Z, as we said, my axis Z is perpendicular to the plane of the surface of interest. This is Z, and Y axis is along the surface. Okay, so now if I want to find the position of the center of pressure, this is my total Y prime. So here Y prime is equal to Y of C, which is the distance from here to C, plus the term that we were talking about, which is the distance between C and the center of pressure. Okay, so now what we will do now is that we will consider the general formula Y prime equal to YC plus this distance. So to find this, first, what is Y of C? To find Y of C is the distance here, this one. Okay, so to find this distance, it's very simple. All we have to do is we should consider the inclination angle theta. So we know what is the value of theta. Theta is 60 degrees, and you can here, they should provide you if you want with this distance. So you have 10. Look, this is 60 degrees. Okay, this is 60. this is 60 degrees, and you have that this distance is 10 meters. So y of c is simply 10 over sine 60. So yc is equal to 10 over sine 60. Okay, and now you should add to this term the distance between C and the center of pressure. And we have seen together that the expression of this distance is given by the following. For the case of negligible negligible P0, this distance can be calculated as this one. So it's Ix over Yc times A. We already found the value of Yc. A is the area of our surface. The surface is a circular geometry. So you have a gate of circular shape. How you find its area? You just do pi r square. Okay. So this area here is equal to pi times the radius square. This is A. Okay. We still need which parameter? We still need Ixx. So Ixx is the inertia, is the second moment of area about x-axis, and we have seen that for a circle it's pi r4 over 4. So all I have to do is to calculate the value of I and then replace back in this formula. Okay, so now you will get the total distance y from the free surface. This is 11.6. So you can deduce that this part, this is y of c. This is the distance from the free surface to the centroid. Okay, and this is the distance between the centroid and your center of pressure. Okay, so you are free to give what you want. If you just want to calculate this, you should tell me that it's located below the center of pressure with this distance. And if they ask you to find what is its distance from the free surface, you should add to this distance y of c, which is the distance between the free surface and the centroid of the area. Okay? Any question on how we located the point of application of the force? Okay. Now, concerning the x position, as we said, x position of the center of pressure is equal to x position of the centroid, and it's very simple. It's here. So this is x of the centroid. So just it's at the axis of symmetry. It's along y-axis here. Okay. So it's along the axis of symmetry of the gate. This one. So this is, if you want to put it in 2D, this is the location of the center of pressure. It has same x of c, and it is below the center. Now, after getting the resultant force and its point of application, they are asking the following. They want to determine what is the moment that would have to be applied to the shaft to open the gate. Okay. So look here, let us do an analysis of what is happening. Water is applying, so this is the location of the center of pressure. This is the point of application of the force. So if I want to illustrate my force here, my force is acting at this point. Okay? So it will tend to do what? This force will tend to create a moment about this shaft here. So you have a shaft here. Okay, this is a stop. So the water is tending to create a moment about this point in the counterclockwise direction. So if you want to open the gate, what should you do? To be able to open the gate, you should apply a moment that is at least that should be able to oppose the moment of water. So water, okay, will try to, you have a stop here that will not allow, that will keep your gate closed. If you want to open your gate, you should apply at least a moment that is opposing the moment created by water. Okay? So now what is the idea? The idea is to find what is the moment created by water to be able to know what should be the minimum moment that I should apply on the shaft to open the gate. So first, I am sure that this is the moment I should apply on the shaft to open the gate should be opposite to the moment created by water. Okay, so it should be clockwise. And to know its magnitude, what should I do? I should find what is the moment of the resultant force of water with respect to my shaft. Okay, so here, since you are applying your moment on the shaft, then you need to determine what is the moment of the resultant force about the shaft. So here, if you are not interested in the moment about the stop, because now the moment about the stop is the moment needed if you want to apply a couple at this location. But since you are applying a couple on your shaft, then the couple on your shaft should oppose the moment of Fr about the shaft. Okay, so to do so, you need to determine what is this distance. And since your shaft is passing by the center of your circle, then this distance represents what? This distance represents the one we talked about, which is calculated by Ixx over YC times A. So this is the distance of interest. Okay. So then what we should do, we should find the moment of the force created will be this distance times, so this distance times the force Fr. Then I should apply a moment to oppose this force to be able to open my gate. Okay. Any question on this? Okay, so we will do a lot of problems to practice on forces on submerged surfaces. Yes, I will upload everything. Today I will upload the PDF and I will upload the recording. Okay. Yeah, let's see you next time. Bye bye.
Bye, doctor.